Good morning and good afternoon, everyone. My name is Xiongxin Chuang. I'm from Nîmes, China. Thanks for the invitation of conference to give me this opportunity. Now, I will report about the research progress of DCC in Nîmes. My presentation has 7 parts. We all know that nowadays the global digital economy is booming and becomes a prominent part in our economy. In the optimization of a global digital economy structure, the digital translation of traditional industry has become the leading factor, which embraces both challenges and opportunity to metrology. CIPM has established a task on the digital SI. Following this lead, facing the new demands from the industry, Nîmes has made some research on metrology scientific data and metrology digitalization. The Metrology Scientific Data Center, short for MSDC, was founded in May 2020. Now, there are 15 researchers. We still have a shortage of technical talents and plan to enlarge our team in the future. Our center is the integration of a network center, information center, and the data center of Nîmes. There are 5 function departments: office, network information lab, metrology data lab, digital metrology lab, service, and publicity lab. The current digital metrology work of Nîmes is focusing on the building of digital metrology system of DCC. However, how to achieve this goal? There's no way to go. From the traditional paper certificate for laboratory calibration, upgrade to the electronic certificate for remote, online, high-frequency calibration, and then to digital calibration certificate for digital metrology. Some important infrastructure are needed, including the DSI guidelines for expression measurement data, basic information security service, and communication frameworks and protocols suitable for remote measurement and digital metrology. Some typical examples of combining metrology infrastructure, industry metrology, and digital certificates into system needs to be developed. Dear Law, we have translated DSI guidelines of SmartCom project into Chinese. The Chinese translation of DSI guideline took about 2 months, and 5 Nîmes staff and 1 PDB employee participated in the translation. This translation work has depended on the Nîmes staff's understanding of DSI design principles. The Chinese version guidelines were effective in enhancing the dissemination of DSI in China. The standalone validation software had been developed according to the SI format specification and the correct semantics of ULITs. To help people convert measurement value into DSI format, we have developed an online DSI conversion software for real quantities. With this software, people can convert a measurement value with a specified ULIT and specified uncertainty into DSI format without learning how to convert from scratch. In order to help people check whether their DSI data is qualified, we have developed an online DSI format validation software. Using this software, people can verify whether a piece of XML format complies with DSI rules. To adopt the developed the digital economy, it's necessary to develop remote online high-frequency calibration service. electronic calibration certificates, digital calibration certificates, and raw measurement data must comply with metrology specifications, information technical standards, and information security specifications. In China, electronic evidence must have the attribute of credible time. If the electronic measurement data needs to be regularized as electronic evidence, the trusted and accurate time-step service and the regularized information encryption technology are necessary. A safe and credible DCC needs trusted time-step to issue its information security. So, we have developed the reliable and accurate time-step service traceable to UTC NIM, with time traceability to UTC and attends time uncertainty data. In order to issue the credibility of time-step system itself, our network time server had been calibrated by NIM. Our time-step system passed the judicial appraisal evaluation in China. Our quality system is also accredited by CQC in China. In conformity with the requirements of Chinese calibration standards, we attempted to apply DCC structure from PTB to express NIM calibration certificates using bilingual Chinese and English. The standalone DCC format validation software had been developed using the DCC and the SI format documents from PTB. The DCC of NIM implemented by DCC structure of PTB can be verified by tracing from PTB. For example, a NIM temperature DCC passed the verification of tracing and obtained the gold quality level. From NIM calibration certificates in the fields of length, mass, temperature, and time frequency measurement, we attempt to express information of calibration instrument, organization, reference technical documents, environmental conditions and locations, and the results use DCC format. There are 4 preliminary results. First, basically, the structure of DCC from PTB is applicable to NIM calibration certificates. Secondly, we think a calibration specification database is needed to standardize the expression of the technical documents referenced by calibration. Third, in order to support multi-language, sometimes needs to be modified. Last one, the integration of picture, text, and data information needs to consider how to achieve truly machine readable. How to use the DCC in remote calibration. How to use the DCC to realize machine readable. We'll need a complete example to illustrate. Therefore, we're trying to develop an example of remote time calibration of traffic cameras. In the example system, NTP protocol is adapted for network time calibration. DSI is adapted for measurement data. DCC is adapted for measurement certificates. Timestamp and digital signature are adapted for information security. We are trying to establish an ECC-DCC alliance blockchain system. In this system, ECC-DCC is a tamper-proof, non-repudiation, highly traceable, and swift to verify authenticity. The blockchain system will provide a reliable, credited system in the fields of measurement and collaboration. Currently, we are developing system structure and related key technology. For the progress we have made, we appreciate the support from SmartCom project team, especially the help from PTB. NIM looks forward to more exchanges and cooperation on DCC development with other national metrology institutes and the related institutes around the world. Thank you.